Well, this is the News Diary. Thank you very much for staying with us. And as you commence your Friday morning, remember a quote by Dr. Seuss that said, "You have brains in your head, you have feet in your shoes, and you can steer yourself in any direction you choose." Thank you for staying with us, but we're now honorably close to our sister station, that is Spice FM, where a conversation is currently ongoing with Adam Ahmed, who is the founder and CEO, Camhurst Ecosystem, and the discussion so far is about the transformation of Kenya's construction industry through the 3D technology. Enjoy the rest of your viewing. I'll see you again at 10 a.m. My name is Anki Doris Umbat.
These huge steel pillars that the system is bolted onto has to be bolted onto these concrete blocks. These concrete blocks can take 28 days to cure. And secondly, they need cranes because it's so heavy, 3 to 6 tons. We alternatively created a robot on tracks that can be easily assembled and dismantled in 3 to 6 hours. So instead of waiting 28 days, ours is set up in 3 to 6 hours, maximum 1 day. It's light enough for 2 people to assemble it without a crane. It's easy enough to put into a 20-foot container and send it to Kenya or send it anywhere we want it to. So we focused on what's stopping this amazing technology being adopted by construction companies around the world. And that's what the R&D had focused on. The second thing was to bring the price down. Now, on average, most of our competitors charge over $500,000 for one of these robots. We charge $250,000. We provide not just the robot, we provide the mixer pump, the diesel generator, the laptop, the software, everything a construction company would need for them to start printing homes. And that, again, is a game changer because we're providing a complete solution. One of the biggest problems I found was they just can't build enough of them. So most of the other competitors, they're taking a year and a half to provide companies who order a robot. We can build any quantity because the factory I've set up in Greater Manchester, we can scale up quite easily. It's like a car manufacturer, Eric. A car manufacturer does not make the windscreen or the doors or does not make the engine or the seats. They just bring in from various suppliers these components. They're assembled in the car factory, tested, and off it goes. And we've done the similar thing. We've got engaged some of the best suppliers once we created the robot. And now we're going to be just towards the end of this month, beginning of next month, bulk quantities of the components are going to come in. We've already trained assembly teams to assemble, test, go into a container, off it goes. And just like I was in Nigeria, October of last year, there was an organization where we signed an MOU for 1 million social housing. Their orders are going to start going out in the next 60 to 90 days. Similarly, I was in Central African Republic. Like I said, on the 15th of this month, we signed an MOU directly with the Housing Ministry. We have orders from various countries, including Germany, Czech Republic, Switzerland, Argentina, Brazil, where we're going to be assembling these robots or building these robots, sending them to these countries. So towards the end, from July onwards, we're going to start seeing show houses pop up. And these show houses, again, will bring in more orders because there are some people who are happy to travel to Manchester, look at the robot printing a wall. That's what we do on open days. We demonstrate this, and then they're ready to go ahead because they want to be the first in their city to use the technology. Who doesn't want to build faster? Who doesn't want to build cheaper? Because if they can build for less, the construction companies can make more profit. They can pass on some of that saving to the end user.
It's going to be affordable to buy such a house. What I'm not getting, Adam, is over 50% cost reduction from the others to what we're having now here, the Camhurst robot. What has made it so much cheaper?
Okay, so we designed it in a way. The others have overcomplicated it. They're like the first mobile phone that came out, and we're like, the latest Samsung or iPhone. We focused on we learned from them. And so by making it simpler and using technology which makes economies of scale as well, because they're not using economies of scale. We're like the Henry Ford was to the motor industry, that's who we are to the 3D concrete printing space. And 3D concrete printing, on the other hand, is called additive manufacturing. That's the right word for it. So economies of scale and making something which you can mass produce. They never created those robots. And the second, so one type of robot is called a four-legged gantry system. So you've got 4 legs, huge concrete columns, which the system goes onto. And like I said, it has to be, supported. The second type of robot, you've probably all seen it, the videos of those arm type of robots that build cars.
Yep.
Yeah.
Yep.
Now that's an ABB robot. There are companies who are making those robots with 3D concrete printing. But the problem is that there's a limitation to the width, the height of those arms. So those robots are not really the right solution. Even they look great. You can see the head of R&D, Ed Rowland, he was involved with one of these companies building that type of robot. It looks magnificent, the way it works. It's on a track and the way it works. But the problem with those type of robots are that because it's only limited height and width, you have to keep moving it. There is a company which built a building in Dubai with 3D concrete printing using the arm type of robot. They had to move the robot 120 times. Every time you move it, you have to calibrate it. So our system is a frame system on a track, and so you can build a huge wall without having to keep moving it.
What's the element of saving that you make using this technology? One would assume that if you're going to build a basic 2 to 3 bedroom, that the costs are going to be more or less, the same, right? So what do you save by using this technology on that?
Good question. You actually use a little less material because the waste that we create is minimal. Then you create a savings by not having formwork, because the formwork is costly and it takes a long time, not just to set it up to get rid of it. The other savings is that where the robot only builds the walls of a house. So the foundations is done in the same way. So there's a misconception the robots are going to take people's jobs. Not at all. If there was enough skilled labor, there won't be a housing crisis around the world. So we're creating jobs because the foundations are done by the people, the construction companies in the normal way. The robot builds the walls of the house super fast. Then you still have, we obviously need people, electricians, plumbers, roofers, landscapers, gardeners, and all of those other trades. And we are looking to set up academies, Camhurst Academies of Excellence throughout Africa and around the world, where UK standard artisan tradespeople, we were going to create an army of artisan tradespeople. We're going to do all the other associated trades. We are also welcoming construction partners who are already working in this space. I was with somebody yesterday in Kenya. He's building a 33-story high building here, a hotel and apartments. And we're looking for construction partners. We're looking for investors. We're looking for strategic partners. And we want the governments to wake up and realize if they don't embrace the technology, if you keep doing the same thing, you're going to have the same results. And when you embrace technology, you bring more efficiency into it, you can build faster, and you can solve this housing crisis in many regions, in obviously in Kenya and around the world.
The competition you speak of when it comes to the innovation of similar technology, work because, or we understand they work because we've seen what they can do.
Sure.
Now, you say that your technology is better,
yes,
and then it can do what some of these other technologies cannot do.
Meaning we took away the problems associated with the other companies scaling. That's what
I'm asking. You see, if the robot exists, that's proof of concept that the robot does exist.
For sure.
But the proof of concept of the buildings that this robot can actually produce.
Good question. Now, good point. A house is made up of walls. You know, if you can build a wall, you can build a house.
Build a house.
So we have, for the last 2 years, built hundreds of walls. because we've been testing different cement materials, different things. So in USA, where we first made this robot with our, along with our cement partners, it was rigorously tested. Then we shipped it over towards the latter part of last year to United Kingdom, and because that's where I obviously am based, that's where we ended up again doing lots of tests, building walls. And now that all the testing has been done, the robots next month are being produced in larger quantities to go out to different sites. I'm 110% confident that not only will we build these obviously houses or any type of building, but we'll be building them in a better way. And the reason I say better is because yes, we can use that special mixture of Portland cement and use steel that is available in most places. But because geopolymer is an eco-friendly cement, we could be producing CAM polymer, which is more suited for 3D concrete printing. And we also have other eco-friendly cements. Now, what I want to go and say we can build better homes is because our construction methods we are trying to use are better. Now, I don't know if you know this, but if you build a house with normal Portland cement or steel, the average lifespan is 60, 80, maximum 120 years, depending on the quality of the cement. Now, when you start to use things like, instead of steel, you use basalt. FRB, fiber reinforced basalt. Basalt is volcanic rock. So we're going to be using, where possible, basalt instead. Because steel starts to rust as soon as it's on site or goes into concrete. And over time, the biggest problem with structural integrities or problems is because the steel has deteriorated and rusted inside. So basalt is volcanic rock. If you build a property with basalt and CAM polymer, the building will last over 1,000 years. It's more hurricane resistant, more tornado resistant, more earthquake resistant.
The